Hello and welcome to this video. Over here I'll be giving you a short tutorial on how we can manually perform atmospheric correction on satellite data. The process is a little lengthy, however it is definitely useful for any purpose for which we might utilize it. So the first step in manual auto atmospheric correction of satellite data is to find the metadata of the satellite image on which you want to work on. Metadata usually ends with an MTL, and if it's hard for you to determine which is the metadata, all you have to do is just right click on it and go to properties. If you go to properties, you will see that this file ends with an MTL. So this is our metadata file, right? So when you open the metadata, it is recommended that you open it in WordPad and not Notepad. So let me just open it in WordPad. Okay, this is our metadata file, right? Why do we need this metadata? That's because we need certain values for which we have to perform certain calculations. The calculations are very easy, so don't worry. We need to create an Excel sheet. In the Excel sheet, you need to form some columns or so the first thing we need is the reflectance multiband. In order to find the reflectance multiband, you have to scroll down in your metadata and look for reflectance multiband. Just scroll down and you'll see here reflectance multiband. This is our reflectance multiband. So all you gotta do is just copy this value, and paste it. Same for reflectance add band. Now many of you, not many, I guess few, some might wonder why the value is so different. What happens is that we have to reformat the cells. So if you just copy and paste this value, alright, okay, here, right? If you just copy and paste the value over here, you'll see that the format is a little bit different when you view it. However, the value is correct. So all you have to do is right click on it and go to format cells. In format cells, you have to select number and increase the number of decimal places to 5. This will give you the correct value required. Same issue with reflectance multiband as well. Don't forget to include the minus symbol because this is a value, right? So just increase the number of decimal places. It's better to be safe than sorry. 5, right? So I've already found the values over here. Next thing we need to find is solar elevation or sun elevation. So to do that, you have to scroll up and then you'll find sun elevation. Copy the value of the sun elevation, paste it. We need to find the radian of this sun elevation. So we need to convert degree into radian. There is a value via which you can do the conversion manually. However, if time is a constraint, then you can definitely go online and just copy this number, go online and type in degree to radian, right? And just paste the value of the solar elevation and this will automatically convert and give you the number. So I need this number. Just going to copy it and I'm going to paste it. Next, we're going to find the sign of the radian. So just type in equals to capital letter SIN, open bracket, then click the cell of the radian, close bracket and click enter. So this is the sign of the radian which we require in our calculations. Next, open your ArcGIS. So when we perform manual atmospheric correction, we need to do calculations for each of the bands, right? So today we're going to work on 7 bands 1 to 7. Okay, so just add the data. I'm going to first work on band 1. Okay, so I think I'm going to change the name because it might get confusing later if I have to stack the images. So I'm going to keep it as band 1. Right, and since I don't have a search icon over here, I'm going to go here, click on this and then type in raster calculator. When you find the raster calculator, click on it None. We found certain values, right? We found certain values, that is the reflectance multiband, reflectance add band, and we need all of these values in our calculation. Okay, so the formula is we have to first type in the reflectance multiband value. So the reflectance multiband value was this, right? So just paste it. Then you have to put in the multiplication symbol, open bracket, then double click on the name of the layer, close bracket, then plus, and then the value of the reflectance add band, which is this. Or you can simply just keep it as minus 0.1. So I'm just going to keep it as minus 0.1, minus 0.1, right? Then you have to divide it by the sine of the radian, the value which we derived, which was this. So just copy it and then paste it and then click on OK. This will perform the atmospheric correction function. So let's just wait for it for a while. It might take a while depending on your computer or your RAM, your hardware. So if you zoom it in and if you just disable the previous layer, if you just disable the newly formed layer, which is the calculated value, right, you can clearly see that the atmospherically corrected satellite raster is a lot more crisp. The details are a lot more visible. So we can remove this, right? And I'm just going to rename this as band 1. Okay, so we have to do the same thing for band 2 as well. Band 2, 3, 4, 5, 6, 7. Let's go to raster calculator and type in the values 0.0002. I think I'm wrong. Yeah, just copy paste the values. So just copy this, paste here, multiplication symbol, plus, open bracket, then add in the reflectance add band, which is minus 0.1, close bracket. Oops, I missed something. Yeah, so multiplication symbol into open bracket, the name of the layer, which is our band 2, close bracket, plus, open bracket, minus 0.1, close bracket, divided by the sine of the radian. V. Right, so this is the multi-band. This is the layer name. I didn't change the layer name over here. We can change it later. Then this is the reflectance add band value, and this is the sine of the radian which we calculated in our Excel sheet. Then click on OK. You have to carry out this process for all the bands from band 1 to band 7, right? After you carry, okay, yeah, it's done. So just disabling this band over here, and yep, this is a lot more crisp, right? So we can remove this value, we can remove this raster and just rename this as band 2 in order to avoid any confusion. Let's do this on band 3. Band 3, go to raster calculator, type in the same values, right? So it is, copy this, paste this, then into symbol, open bracket, double click on the layer, close bracket, then plus, and then the the add band, which is minus 0.1, close bracket, divided by the sine of the radian. C, Control V. Right, and then just click on OK. In the next video, I'm going to show you how we can stack and clip the images which we have derived, the atmospherically corrected images. So if we do that again, you will see the difference. Remove the old image and just type in band 3. Right, so you have to carry this out for bands 1 to 7 or whichever bands you want. Band 8 is panchromatic band. Oh, and I'm performing this on satellite data which was derived from Landsat 8 collection 1 level 1. Alright, so I'm going to see you in the next video, as if my channel has subscribers, but still. Okay, all the best.